In this video, we will go over another type of integral problem. This will be partial fraction. I'm calling it a type 3 because in this problem, we will go over distinct quadratic factor. And in the last two videos, we went over distinct linear factor and repeated linear factor. And so if you want, you can pause the video here and attempt this problem. So this inside piece right here, x squared plus 4, is a quadratic factor. And so for partial fractions, we need to do something a little bit different. So we still say a divided by x, because we have an x here, plus. Now this is where it gets a little bit different. Because it is a quadratic factor, we say in the numerator, it's going to be bx plus c. And now, like what we did before, we multiply by the common denominator, which will be x times parentheses x squared plus 4. And so we would get x squared plus 8 is equal to a times parentheses x squared plus 4 plus parentheses bx plus c close parentheses times x. Now we can expand. So a times x squared is ax squared, a times 4 is 4a, bx times x is bx squared, c times x is cx. And now we will group each term. So we have an x squared term, we have a 0x, and we have an 8, a constant. So we will say is equal to parentheses a plus b, close parentheses x squared. I group the x squared term, plus cx plus 4a. And so we can say that 1 is equal to a plus b. This involves the x squared term, and 0 is equal to c, and 8 is equal to 4a. And so we know that c is equal to 0, and we also know that a will equal 2 because 8 is equal to 4a, divide by 4, a is equal to 2. Finally, to get b, we can say that 1 is equal to 2 plus b, and so b will equal -1. And so now we replace. So we want the integral of 2 divided by x dx because a is equal to 2, minus because, b is -1, so we can put a negative in the front, the integral of bx plus c. We know that b is -1, so I put the negative here. And so we have x plus c, and c is 0, so plus 0. And so now we can easily take the integral for both of these pieces. This piece right here, we should do u sub. So u is equal to x squared plus 4. And so du is equal to 2x dx. Divide by 2, divide by 2. And so we can say that du divided by 2 is equal to x dx. And so this piece right here will equal to ln absolute value of x. And then this piece we would get -1/2 the integral of 1 divided by u because we replace x squared plus 4 with u. And taking the integral of this is very easy. It's going to be -1/2 ln absolute value of u plus c. Finally, we can swap u with what we said u is equal to, which is x squared plus 4. And so this is what we get. And this is just a minor thing. Do we need the absolute value on the second term? The reason we don't is because if x is -5, it's still positive. If x is 5, it's also positive. So the absolute value is not essential. And so I change it to a parentheses. And that's all we need to do for this type of problem.